Hello everyone, we are discussing about maximum power transfer theorem. In the previous video, we discussed condition for the maximum power transfer when source impedance is purely resistance and load impedance is purely resistance. Now coming to case 2, if source impedance is complex and load impedance is complex. Here again we have three cases. That is, first case, if only load resistance is variable and XL is constant. If only load resistance RL is variable and XL is constant, then the condition is, I won't derive the condition here, just I will give you note about the how to derive the condition. So what is the condition? Differentiate power. If only load resistance is variable, then differentiate with respect to load resistance and make it is 0. Then you will get the condition is RL is equal to square root of RS square plus XL plus XS whole square. And second condition is, if only XL is variable and RL is constant, then to get the condition is differentiate power with respect to XL and make it is 0. Then you will get XL plus XS equal to 0. These conditions are for transferring the maximum power from source to load when load is varying. If load is varying, again these are the sub cases. First case is if only resistance is variable, and second case is only inductance only reactive component is variable, that is XL is variable. And third case is if both are variable, both means ZL is variable, then differentiate power with respect to ZL and make it is 0. Then you will get the condition is ZL equal to ZS conjugate. That means if it is RL plus JXL equal to conjugate means, if it is RS plus JXS, then conjugate means RS minus JXS. So RS minus JXS. These are the conditions to transfer the maximum power from source to load. Now find the power. Let it be current IL, load current IL. What is the IL? IL is equal to Vs by Zs plus ZL. Now Vs by, this is RS plus JXL plus JXS, RL plus JXL. IL is equal to Vs by RS plus, this is RL plus J into XL plus XS. Now what is the power? Power P is equal to IL modulus of IL square. So this is active power. So consider modulus of IL square into RL. And this is RMS value, IRMS square into RL. So if let it be source is RMS value, so no need to convert this IL into RMS value. So you can take directly IL as RMS value. Now substitute this value in this equation. Modulus means, so Vs square by modulus of A plus JB means square root of A square plus B square. Similarly for this one, so what is P? Vs square by square root of RS plus RL whole square, that is A plus JB. So A square root of A square plus B square. So A square plus XL plus XS whole square. This is whole square, consider here, into RL. Finally you will get the power is P is equal to Vs square by RS plus RL whole square plus XS plus XL whole square into RL. Coming to case 3. If source impedance is complex impedance and load impedance is pure resistance value. If source impedance is complex impedance and load impedance is pure resistance value, then the condition for maximum power transfer is differentiate power with respect, this is load power, so differentiate load power with respect to, here the variable is load resistance, so RL, and equating to 0, then you will get the condition is RL is equal to square root of RS square plus XS square. So this is the condition for maximum power transfer in case of if source impedance is complex impedance and so load impedance is pure resistance. Now find the maximum power transfer. So let it be IL. Now what is IL? IL is equal to Vs by Zs plus RL. So here Vs by RL plus RS plus JXS. Now what is the power P? That is maximum power. P max is equal to, here also this is maximum power. P max is equal to IL square modulus of IL square into RL. Modulus of IL means Vs by square root of RL plus RS whole square plus XS whole square. Again it is whole square into RL. So here square and root gets cancelled. Then you will get P max is equal to Vs square by RS plus RL whole square plus X square into RL. This is the maximum power transfer to load when if load is purely resistance and source impedance is complex impedance. Finally, conclusions are: case 1, if source impedance is purely resistance and load impedance is purely resistance, then the condition for maximum power transfer is RL equal to RS and the P max maximum power is Vs square by 4RL. Coming to second case, if source impedance is complex impedance, that is RS plus JXS, and load impedance is RS complex impedance RL plus JXL, then here we have three conditions. That is, first condition is if only RL is variable, then the condition is RL equal to square root of RS square plus XL plus XS whole square. If only XL is variable, condition is XL plus XS equal to 0. If ZL is variable, condition for maximum power transfer is ZL equal to ZS conjugate. And here the maximum power is Vs square by RS plus RL whole square plus XS plus XL whole square into RL. And the last condition is if source impedance is complex impedance and load impedance is pure resistance, then the condition for maximum power transfer is square root of RS square plus XS square, and the maximum power is Vs square by RS plus RL whole square plus XS square into RL. In the next video, we will discuss some problems on this concept. Thank you for watching.